So, Assalamu alaikum, dear students. I hope you watched my previous video in which I have solved the question starting from 20 till 30. And this paper is May-June 24, P21. Now, in this video, we are starting it from question number 31. And in this question, they are saying that which types of electric current are in primary coil and in the secondary coil of a step-up transformer. So, in the transformer, it is very important for its operation that we will provide the alternating current because change in current will cause the change in magnetic field, which is actually required for the proper working of step-up transformer. And this way, the EMF will be induced in the secondary coil. So, for that, we will see that A option is correct in it. Okay. Next question number 32. A scientist fires alpha particles at a very thin sheet of gold and detects the particles that pass through. Which statement about the results of the scattering experiment is correct? A option is saying that alpha particles are attracted to the nucleus of the atoms in the metal sheet. Not at all. Why? Because alpha particles, they are having the double positive charge on them. All right. So if they have double positive charge on them, you know that nucleus is also positive. So positive will not be attracted toward each other. Okay. Then in B option, they are saying that half the mass of the atom is concentrated in the nucleus. No, most of the mass is concentrated in the nucleus, not half of it. So B option is also not correct. In C option, they are saying that most of the alpha particles are deflected. No, only few of them are deflected. So showing that the nucleus is very dense. So from here, we can say that this is the wrong option. So only D option is correct in it. The 33 question, the notation represents the nucleus of a gold atom. The relative charge on a proton is +1. What is the relative charge on the gold nucleus? So the relative charge on proton is +1, and they are asking for the nucleus. So in the nucleus, we have 79 number of protons. So here, number of protons are written. So from this notation, we can say that +79 is the charge on the nucleus. 34 question. An isotope of hydrogen has the nuclide notation this one, 1H2. How many neutrons are in the nucleus of this isotope? And what is the relative charge on nucleus? To calculate number of neutrons, you know that this number is actually the sum of number of neutrons and number of protons. And here this is the number of protons only. So you can subtract these two very easily. So when you are subtracting them up, you have number of neutrons. So number of neutrons plus number of protons minus number of protons will give you the result. So 2 minus 1 is equals to 1. So it means that we have one number of neutrons. So we have A and B option for one. But what is the relative charge? Charge definitely depends on the number of protons. So we have one here. So A option in it is correct. Okay. Question number 35. The radioactive source is placed near a detector. So this is the radioactive source, and here we have a detector. The radiation arriving at the detector from the source is measured for 10 minutes. Like these are the radiations which are coming out, and the detector is keep on detecting, but it is for 10 minutes. But different materials placed between the source and the detector. So here, in between them, they are placing the different materials and keep on checking that what is the effect of placing the materials on the values. Okay? And then here, material between source and detector, initially none. And they will observe that they have 526, 5626 counts. Then sheet of paper, 5629. Did you notice here that when you will place sheet of paper, the count, that what is the effect on count, right? 5626, then 5629, and then with the thick sheet of aluminum. You know, alpha particles are blocked by the sheet of paper, but we notice that there is no, like it is increased in it. So it means that there are no alpha particles present inside this radioactive source is not consisting of alpha particles. So thick sheet of aluminum, if you are placing them up, you notice that how drop it is, like it's a very huge drop. And beta particles can be blocked by the thick sheet of aluminum. So that's why it means that beta particles will be there in the radioactive source. When you place thick sheet of lead here in this area, then the radiations will also be dropped. Like when you are going to count them up and see the reading on the detector, it will be 255. And gamma radiations are blocked by a thick sheet of lead. So from this observation, we can see that which types of radiations are present. So they are also asking the same thing, that which types of radiations are emitted by the source. From these two values, you can judge that here we have beta particles which are present, and between these two readings, you can see that gamma radiations are also there. So C option in it is correct, that beta particles and gamma rays both are present in it. Next question. The reading on a detector placed near a radioactive material is 536 counts per second. Background radiations are also given, which is 44 counts per second. Half-life of the radioactive material is 34 hours, but they want that what is the reading on the detector after 68 hours. So our first target is to see that how many half-lives are there. So to calculate the number of half-lives, we will divide the total time by the half-life. So in this way, we will be able to get the number of half-lives. So number of half-life equals to 68 divided by 34, right? So when you are dividing these two, you will get 2 answer. Okay. So number of half-lives in it is 2. So now we will start from this. So total counts on the detector is 536. But we have background radiation as well. So our first step is to subtract the background radiation from the main value which is on the detector. So we are going to subtract 536 from 44. So when we are subtracting them up, 536 minus 44, so our answer is 492. Okay, 492. So now we 2 times we have to subtract, we have to divide 492. Okay, so here 492 divided by 2. So after first half-life, our reading will be 246. When you will divide this, you will get 246. So after second half-life, 246 divided by 2 once again, your answer will be 123. But this is not the final answer. What we are going to do, we have to add the background radiation in this reading as well. This is our final step, plus 44 in it. And the answer is 167. Now, you know that many of the students will tick the 123 counts because they are obviously noticing this thing that it is also present in the options. But 123 is not the answer. 167 is the answer. Why? Because the final step is to add the background radiations once again. So that answer is 167. So B option is not correct. D option is. Next question. A planet in the solar system is at the point in its orbit where it is closest to the sun. Which row is correct about the orbital speed and energy in the gravitational potential stored? Whenever the planet is closer to the sun, its speed is maximum. Okay, speed is maximum, and when it is far away from it, its potential energy is maximum. But here they are saying that it is closest to the sun, so its speed is maximum, but its gravitational energy is minimum here. So B option is correct. What is the main source that powers the sun? We know that there is a fusion process, nuclear fusion process is occurring there in the sun. So, first of all, we will see that burning and nuclear fusion, these are not the options. So, definitely, nuclear fusion will be there. And in the fusion process, hydrogen is converting into helium. A galaxy is 3 into 10 raised to the power 20 kilometers from the Earth. At which speed is the galaxy moving away from the Earth? So here we are using the formula of Hubble's constant, that is equals to speed divided by distance. And as here speed is needed, so speed will be equals to Hubble's constant multiplied by d, which is the distance. We know that the value of Hubble's constant is 2.2 into 10 raised to the power minus 18. And the distance is already given to us, which is 3 into 10 raised to the power 20. So when you are going to solve these two, your answer is 660. But here we have two values for 660. So which one will be correct? As we know that here the data is given to us in kilometers, so it will be kilometers per second. A option is correct here. The last question of this paper, an astronomer observes a distant galaxy. The table shows how the distance and the speed of recession of the galaxy are determined. Which row is correct? First of all, distance. Distance should be measured by the brightness of the supernova in a galaxy. What is how the brightness of the supernova in the galaxy? Actually, supernova is the super duper blast in which you are able to see the brightness of it. So you will see that A option it is correct. And B is also there. But when we are talking about speed of recession, that is change in wavelength of starlight from the galaxy. Just you have to recall the concept of redshift in it, which depends on the changing wavelength, because to calculate speed of recession, definitely redshift will be the part of it. So according to that, we have A option, which is correct. I hope you like my this video. And today we have completed our this paper, which is 0625 summer 24 P21. Please like and subscribe my channel, and just wait for my next video. Take care. Allah Hafiz.